Hello, welcome to my channel again. Now we are on the episode 3 of the Claude Code production series. Today's topic is the MCP servers. CLAUDE.md tells Claude what to do. Hooks enforce what Claude cannot do. An MCP server adds what Claude can do. It gives Claude new tools that did not exist before. Tools that your call database, read your files, query your APIs, generate your slides, anything. This episode builds a working Python MCP server from scratch with two tools, a SQLite query tool that accepts SQL and return rows, and a file read tool that returns file contents within a bounded directory. I wire both into Claude Code, demonstrate Claude calling them live, and explain the 4 failure modes that cause MCP tool to stop working silently. I will also show a real-world example. The PowerPoint MCP server I use generate the slide decks for this series. So you can see what a production MCP tool integration looks like in a working session. Before the code, let me show what an MCP server actually is and where it sits relative to the tools you have already seen. You have 3 layers of configuration in a Claude setup. CLAUDE.md is the context. It tells Claude how to think about the project, what the repo contains, what workflows to flow, what conversations to use. It influences the model's decision. It does not add capabilities. Hooks are enforcement. They run in the shell before or after tool calls and enforce constraints, blocking dangerous commands, saving state, gating commits. Hooks are the gate tools that already exist. They do not add new ones. An MCP server is capability. It registers new tools into Claude Code. When Claude is working and needs to call one of your tools, it sends a structured request to your server. The server receives the input and runs the code, any code, and returns a result. Claude reads the result and continues. The model architecture matters here. MCP servers are out of process. They run as a separate process that Claude Code communicates with over a local socket or sub-process pipe. Claude cannot see the server's internals. It only sees the tool name, the input schema, and the return value. This is the correct boundary for adding external capabilities. The canonical use cases are reading data from a database or API that would otherwise require copy-pasting, generating structured artifacts like site decks or documents, calling internal systems Claude does not have credentials to reach directly, wrapping expensive or slow operations that needs catching. To build an MCP server correctly, you need to understand 3 primitives it exposes. The model context protocol defines 3 types of things a server can expose: tools, resources, and prompts. Tools are primary primitive. A tool is callable function. Claude decides when to call it, passes typed inputs, and receive a returned value. Tools are correct primitive for anything that requires computation. For example, database queries, API calls, file generation, calculations, and etc. This is what you built in this episode. Resources are second primitive. A resource is a URI that returns content, similar to a file endpoint. Claude can read a resource to get data. Resources are the correct primitive for reference that content that does not change based on inputs. For example, a schema file, a configuration template, a lookup table. Resources are read-only and static. For most production use cases, the tools are more useful than resources because they accept parameters. Prompts, those are the third primitive. The prompt is a pre-configured message template that Claude can retrieve and use. They are less commonly used in Claude Code setups, more relevant for chat interfaces when the user selects from a menu. I will not build a prompt in this episode. For production Claude Code setups, you will need tools. Tools give Claude the ability to take actions and get fresh data. That is the capability gap that MCP exists to fill. Let me show the minimal server structure, the code that connects everything. I am using FastMCP, the high-level interface from the official MCP Python SDK. FastMCP handles the protocol boilerplate, the JSON RPC transport, the tool schema generation, the request routing. You write Python functions with type annotations. FastMCP turns them into MCP tools. The server is 3 imports, one MCP instance, and a main block that calls mcp.run. That is the skeleton. Every tool you add goes between the imports and the main block. 2 things matter in this structure. First, the tool decorator. It registers the function as a callable tool and uses the function type annotations to generate the input schema Claude receives. If Claude is about to call your tool with wrong types, the validation happens before your function is invoked. Second, the docstring. Claude uses the function's docstring to decide when to call the tool. A clear specific docstring is not a static preference. It's a function. Write it for the model. The server runs as a subprocess that Claude Code manages. When Claude Code starts, it launches all registered MCP servers and keeps them running for the session. When the session ends, Claude Code kills the process. This means your server code runs continuously. It is not one-shot script. Any global state you set up in the server persists for the session. Let's go to the MCP server code in the Visual Studio Code. Let's check out the server PY. It registers two tools with FastMCP, as you can see. One is the query DB and the other is the read file. As you can see, MCP tool decorator generates the schema and docstring guides Claude MCP run. So in our project directory, the tools are in the tools folder, and in the data folder, we have a sample DB. Let me build the first tool, the SQLite query tool. SQLite query tool takes a SQL string and returns results as a JSON. Here is the full implementation. The first thing the tool does is a select guard. It checks that the SQL string starts with select after stripping white space and converting to uppercase. If it does not, it returns an JSON error object immediately. It does not raise an exception. It does not call SQLite tree at all. This is the same defense in depth pattern from the NL to SQL episode in the Python AI series. The guard lives at the tool boundary, not in the model. The second thing is explicit error handling. The try and except warps the entire database code. If anything fails, connection error, bad SQL string, or missing a table, something like that, the function returns a JSON object with an error key. It does not raise. Exceptions in an MCP tool surface in a strange ways, depending on the client. Explicit error returns more predictable. The third thing is structured output. The function returns a JSON string, not a Python object. MCP tool does return string. If you want Claude to parse the structure, return valid JSON and document in the docstring what the schema looks like. The DB path parameter defaults to the sample DB in the current working directory. In production, you will set this from an environment variable or accept as a parameter to a scoped session. Let's go back to the Visual Studio and see the query DB code inside the tools. SQL is stripped and uppercased, checks the database. As you can see, if the first token is not allowed first tokens, which are select, with, explain, and pragma, for example, update or delete, is not allowed. The second tool follows the same design principle with a different enforcement concern. The file read tool takes a file path and returns the file contents as a string. The critical design decision is the path bounding. Without a path bounding, this tool is read everywhere, anywhere tool. So Claude Code could request any file on the file system. Credentials, private keys, operating system files. Imagine it. That is not what you want. The tool should only read files within an explicit allowed directory. Here's how path bounding works. You define an allowed directory, constant, and an absolute path. So the data directory inside the project resolves with OS path, absolute path at the module load time. When the tool receives a path input, it resolves it to an absolute path with OS path to absolute path function and checks that it starts with allowed directory. If it does not, return an error. If it does, read the file. This defense at the tool boundary, even if Claude is convinced by a prompt that it should read a file outside the allowed directory, the tool rejects it before touching the system. The check is in the Python code, not in the CLAUDE.md. The tool also handles the common error cases explicitly. File not found, permission denied, encoding errors, like that. Each returns a JSON error object. The tool never raises. Let's go back to the Visual Studio Code and read file tool PY is under the tools. Look, we have an allowed directory as a parameter here. So it resolves. Also, the candidate is resolved here. And it checks the candidate is relative to allowed folders or not. If the candidate exists, then it's okay. If a candidate is a file, then it's again okay. We can continue. And we can dump the file and read the text from that file. Otherwise, it's not allowed, as you can see. So the errors are handled like that. When the file dump is errored, the file is not valid, UTF-8, or else we have a permission error, or we have an unexpected error if we fail there. Now let me show how to write the server into Claude Code. MCP servers are registered in Claude.json at the project root. The MCP servers blocks map a server name to its command, arguments, and working directory. Here is the structure. The server name, the SQLite tool in this case, is how Claude Code refers to the server. The command is executable, Python most of the system, or the full path of your virtual environment's Python binary if you are using a dedicated environment. The arguments lists what follows the command, path to the server py. The CVD field is the working directory the server process starts in. This is what determines where relative paths like sampledb is resolved. There is a CLI shortcut, CLAUDE.mcp add, followed by the name and the command. The CLI is convenient for interactive setup, but on Windows, it has a problem. When you pass environment variables or Windows paths via the CLI, the shell consumes the backslashes before they reach the Claude Code. The stored value is grabbed. The fix is to register the server via the CLI for the basic command. The open claude.json directly and fix any path values by hand. Use forward slashes or raw JSON strings. One important operational note: mcpServer changes take effect in the next session. Unlike hooks and CLAUDE.md, changes which are reloaded per turn. mcpServers are started once at a session start. If you update the server code, restart the Claude Code session to pick up the changes. How do you verify the server is running? Check the Claude Code startup output. It logs which mcpServer starts successfully and which failed. If a server fails to start, Claude Code continues without it. No error is surfaced during the session unless you check startup logs. As you can see, we have the Claude Code JSON as an example in our folder. Let me start the terminal here and run the Claude. Let's write down the Claude MCP at SQLite tools, and we will give the environmental variable db path of the sample db from our data folder and -- python. Code is the server py from the episode 3 MCP server folder, which is here. So the server py is here. Let's run the command and see if the Claude adds this MCP server or not. Let's make it yes. Now we are seeing the message the SQLite tool is added as an MCP server. Let's check with the MCP command. The harder problem is not wiring. It is knowing when your tool has stopped working. MCP tools fail silently in 4 distinct ways. If you do not know these patterns, you will spend a session wondering why Claude is not calling your tool when the answer is one of these 4. First, server did not start. Claude Code launches the server subprocess and expects it to respond to a handshake. If the server crashes at startup, for example, import error, missing dependency, a syntax error, Claude Code marks it unavailable and continues. Claude has no tools from that server for entire session. The fix is to run the server py manually in a terminal before the session and confirm its start without errors. Second, tool is not being offered. Claude does not call tools it does not know exist. If your tool decorator is wrong, if the function has no docstring, or if the server started but the tool registration failed, Claude will not see the tool in its tool list. The fix is to check what tools Claude thinks it has. Ask directly, what tools do you have available? Or inspect in the Claude Code session logs. Third, the tool is being called but the output is wrong. Claude receives the return value and may misinterpret or silently discard an error response. If you return a JSON error object and Claude does not surface it, the session continues if the tool succeeded. The fix is logging. Write every tool call and return value to a log file inside the tool function. This is the most important debug habit. Fourth, path and environment issues. The server process does not inherit your terminal environment. If your tool code depends on environment variables, they must be set in the mcpServers block using an env field. If your tool code uses a relative path, they resolve from the CVD field in the server registration, not from your project rule. Don't you forget that. For example, query_db function, log debug lines are here. Another tool, read file. Look at those logs all over the place. Let me close with a real example. The PowerPoint MCP server I used to generate every slide deck in the series. The slide decks for this series were not built by hand. I wrote a Python MCP server, the PPT MCP server, that wraps Python PPTX with a set of Claude callable tools. Claude calls these tools during a session to build slides programmatically. The tools the server exposes include create presentation, add slide, add text box, add table, for example, charts, image, set sliding background, formatting existing texts, saving presentation, and screenshot slides. Each tool takes typed inputs like slide index, position, content, and color, and returns confirmation on error JSON. The workflow looks like this. I give Claude a slide design plan, which I wrote earlier in the session. And Claude calls the MCP tools in sequence. It calls create presentation to initialize the file, then it calls add slide, add text box, add image for each slide, then save presentation to write the PPTX file. The screenshot slides to verify the output looks correct and iterate. This is exactly the use case MCP was designed for. An operation that requires persistent state across many steps. A file being built up incrementally. That Claude cannot do with the built-in tools alone. The MCP server holds the presentation object in memory across tools calls. Claude orchestrates the tools call. The output is fully rendered in a PowerPoint file. The same pattern applies to any stateful artifact. A SQLite database being built up, record by record, a PDF being reconstructed section by section, a report being assembled from multiple data sources. 4 things to take away before we close this episode. 1. MCP adds capability, hooks, gate. If you want Claude to do something it cannot currently do, you need an MCP server. If you want to control something Claude already does, you need a hook. These are complementary, not overlapping. 2. Tools are the primary primitive. Build tools, resources, and prompts have their uses. But for production Claude Code setups, tools are what you need 90% of the time. 3. Enforce at the tool boundary. Select guards, path bounds, input validation. For example, these belong inside the tool function, not in CLAUDE.md instructions. The tool runs outside the model cannot override it. 4. Log everything in development. An MCP tool silently fails. Look like Claude choose not to call the tool. Log tool calls and return from day one. It is the only reliable way to distinguish tool not called from tool called and failed. Those are two separate things and you have right to know it. The scripts for this server are in the production Claude Code repository. Episode 4, the next episode, covers context management, the token budgets, compaction, and designing sessions that do not forget. Please subscribe if you like the video. Please hit the like button also, and see you in the next video. Oh, by the way, if you want to try the code by yourself, go to my GitHub and production Claude Code episode 3 MCP server. Everything you need to know is there. Thank you.